So I was perusing through an external hard drive on my computer trying to see what was on it, and these job site photos came up. This was job that I did. It was job number 10284. That means it was the 284th job that my company, Cajun Constructors, landed in 2010. It was a pretty interesting job. It was a sector gate, a pump station, a levee, and some other work, and I thought maybe it might make a good video on how people actually build stuff out in the middle of the water. So I'm gonna do a video on one phase of the job, and if it's popular, I'll finish it up. It's a big job, so it would take us several videos, but yeah, let's give it a shot. So the job consisted of the sector gate proper structure and a bunch of dirt work, including an earthen levee, and the pump station, which is next to the sector gate, a bunch of T-walls, and demolition of the barge gate that they paid me dearly to put in just 3 years before. So if you remember the muck that I got stuck in on the mini-hoe last week, this little canal had like 15 feet deep of the same material, and we had to make a road over it because that's where all our trucks had to come in. Luckily, there was another Cajun job just a few miles away who was finishing up, and he must have sent us 100 truckloads of dirt and broken concrete and whatever, and we just kept dumping it in, and then I bought about $50,000 worth of truck mats and probably another $30,000 of crushed stone, and we had a pretty good road. It held up pretty well, but at the end, all of those new truck mats pretty much were garbage. So if you've watched my other videos, you've probably seen a stack of cypress lumber behind my foundry building. Yep, this is where it came from. Me and some of the guys from work, we all pitched in together and had a bunch of them milled, and I'm still using mine. I don't think anybody's used theirs up yet. This is our dirt subcontractors, dredge or clamshell. They came in and dug the big areas so we could float our barges in, and they're also the ones that did the earthwork on the levee. So this is the first crane we brought to the job site. It's a 300-ton Manitowoc, and it's on a barge, and it's going to stay on that barge for quite a while. It just barely made it under that bridge to get here. This is a little pad working area. This is where our two 150-ton assist cranes are going to live for the next almost 2 years. So I had 3 of these little floaties made. They're made of 12-inch C-channel and a 1/4-inch steel plate top and bottom. They're indestructible. They don't move around when you walk on them. You can put welding machines on them. They were in high demand from day one. I bet they're still out in the field somewhere. Somebody's probably still using them. This is our land-based assist crane. We're tracking it down the haul road. We have crane mats on top of the truck mats, and we have down trees on the outside to make sure it stays put. You absolutely cannot get a crane off of mats in this environment. It will absolutely flip over backwards, sink in the ground, flip over backwards in a heartbeat. I think I'll narrow this video down to just putting in the Cofferdam for the sector gate and excavating. In core speak, it would be a TRS, or a temporary retaining structure, but for the rest of the world, it'd be a Cofferdam, and this is the start of it right here. Now, unfortunately, I can find no photos of the ring girders before we put them in the water. This is a girder system that we owned. We had it in the yard. It probably helped us get the job, because this was a negotiated contract. Anyway, each one is sized where you can put it on a truck. They're not sheet metal, these are heavy steel, and have bung holes in the bottom and the top, and flanges on the end. They bolt together. It's like a big erector set. So we put them together, the whole circle, floated it to the location it was supposed to be, and pinned it into place where it wouldn't move. And then we removed a couple of the sections to get the crane on the interior of the circle so he could reach to drive the sheets around the exterior. This is the sheet piles. The interlock, there's a male and female joint. They're driven, but it's not as easy as you would think. The big yellow vibratory hammer grabs them and shakes with a lot of energy. They don't go in the ground straight. You have to put like a bunch of them halfway down and then up and down and up and down. You have to work them It's a skill putting these things in the ground. If they're not driven straight, then that last pair that you're trying to interlock will never go together. And it also is hard when you're doing walls with 90 degrees or T's in them. Nothing wants to work. You have to drive them straight. They have to be driven straight. So at some point we backed the barge up, or they backed the barge up. This is a subcontractor doing the piling work. Brought in some flexi floats. That's those orange barges with the yellow things attached to them. Those are pretty cool deals. They're 8.5 feet wide. They can ship on a truck. You pick them up and you pin them together. They're like giant Legos, and you can make them very strong. We did a job in Georgia where we put a bunch of them together and put a crane on it. So they used those to build the template to drive the pipe piles in the right place for the bridge that's going to hold up the crane later on. And they had to get them driven before they backed all the way out of the circle. And once they were driven, they closed up the circle, the circular whaler, and drove the rest of the sheets. Now that last 20-30 feet, that's the hardest sheets to drive, because you have to measure out, and then you either shrink the sheets or expand the sheets so it'll come out right at the end. And they use chain come-alongs and whatever. It's a battle, but it probably took them longer to do that stretch than the other half of the whole circle. But they got it totally 100% all the way around, all the sheets driven to grade, and then the ball was in our court for a while. With the ring girder complete, it's held in place by these pin piles that fit these sockets. You can see where they cut the top open and drove it with the vibratory hammer. These are long, these are pretty strong. These keep the whaler in place, because this is one coming down the road. Because right now the thing's just floating. It's pretty loose. We're going to sink it and get it to the right elevation. Okay, with the pile drivers out of the way and the circle complete, we install these brackets. These are to hold this thing at a certain elevation. We can't just let it float on top. It has to go lower. And then we shot the sheets at every intersection of this thing, and we welded a little clip at the top to hold it. They're all at different elevations, but hopefully when it would sink, when we sink it, it will stop it at the right spot. You can also see the 3/4 galvanized with the valve. Each ring girder section has one of those, and that's to let the air out so it'll sink. So the time had come for the sinking. We reached under the bottom and removed the plugs from the threaded holes. And we had done that on land and greased them up real well, so they came out real easy. And then we opened the air valves, and air came out, water went in, and it sunk all of a sudden quite rapidly, and it bent a bunch of the brackets. It went down too low on one side. We had to scratch our heads. So we hooked up the air compressor to these vertical 3/4 inch pipes and put air back in the ones that are on the low side. And then by hooking the vibratory hammer to the pin piles and shaking everything, we got them back up to grade. We got it, it's almost perfectly level. We hung this walkway on the outside of the structure, the TRS as the Corps calls it, or a Cofferdam as most people call them, because it was just convenient, and the operator of the crane needed a way to come and go. So we did that, and then we started up the pumps. We had two 12-inch pumps in the beginning. It's not as easy as you might think, because every single pair of sheets leaks water, some worse than others. You pump and you pump and you pump, and sometimes the leaks seal themselves. We also went around and threw dirt on the exterior, tried to get it to suck in the crack. We dropped plastic sheets, sometimes that worked. We dropped sawdust. But anyway, both pumps ran for a long time before the water started going down. Now our water's not clear, and it's got a lot of debris in it, so eventually it kind of seals itself, but we try to help it along. And you can see in this photo that the ring girder turned out to be pretty doggone level, considering how difficult it was to work on it. Meanwhile, Cajun Deep Foundations, that's the pile driving company. It's actually owned by the same people as own my company, but it's a different division, so we fought like typical subcontractor, contractor. They're building the bridge that the crane's going to sit on, and we have to do this because he's not going to be able to reach the piles to drive them from the outside of the Cofferdam. without a crane that's just so big that the ground wouldn't support it. So we went with a 300-ton crane. We're building this bridge. It was designed by a structural engineer. He inspected it. It's beefy, but it's got to hold up a 300-ton crane, which theoretically could lift 300 tons, so that's 600 tons. And it is not a static load. It's a dynamic because they're driving piles, so it's got to be super strong. So with the welding finished and inspected, it was time to put mats on the top. That's the roadway. The crane couldn't reach him because he's all the way on the other side of the TRS on a barge. So my little floaties came in handy. We lowered the mats on the floaty and rolled them around, or floated them around one by one, and turned out to be no problem. You just pull them with a rope. I can find no pics of walking the crane from the barge onto the bridge. It's pretty nerve-wracking. There's some big ramps that we rent from a fellow contractor specifically for that. There's a nautical engineer involved who has to know the specs on the barge and the water depth and all that kind of stuff. So basically, as the crane goes toward the end of the barge, toward the bridge, the barge goes down, and then he starts up the ramps onto the bridge, and at some point the barge goes up, and then when he gets on more on the bridge, the ramps fly up on the end. It's pretty hair-raising. And I'm hoping I can stumble across some pictures before we get too far, but as of yet, I got no pics. So with the ring girder in place, the steel ring girder at the proper elevation, our TRS, our temporary retaining structure design, allowed us to remove material to the bottom of the lower ring girder, which will be made out of concrete. After that ring girder is complete, we can then lower the elevation to the final cut, which is another probably 10 or 12 feet below the concrete ring girder. So we started removing material using mostly the clam bucket, and we had 3 super operators. I have David Chapman, Randall Riggle, and Aaron Bennett, aka Biggin. And they were just super. They could pick up this muck, turn around and lower the bucket into a dump truck without breaking anything, and release the stuff in a dump truck. On the big crane, we had a skip pan and we had a small track hoe, and he was digging out from under the whaler and putting it in a pan, and we're swinging it out to the mud pit. And we had a guy out there who would swap the cables and dump it upside down. And it was a little slow, but digging under the whaler was a little slow, so that worked out okay. And then finally, we had a stable spot, a lot of sand dumped there and a lot of stone, and that was kind of monumental when you could go down the ladder and stand on something. But we kept pecking at it, and eventually we had cut to the elevation of the bottom of the ring girder. Now, dewatering was a horrible nightmare because the pumps were constantly clogging up with mud or roots, other debris. It just there was no easy way around it. You just had to keep 2 pumps going and one pump being serviced almost all the time. So eventually we got down to where this setup could keep us dry. This is a hydraulically powered submersible trash pump. There's a big power pack up on the bridge. It sends hydraulic fluid through those little hoses. The pump is in the hole, and it pumps water in it. It's pretty easy to pick it up and clean it when it gets plugged up. And that was running for many months, that sole pump. As we worked our way around, we set little 2-inch electric pumps to pump water back to the big pumps, and it slowly became more and more manageable. So we were able to stop all the big leaks, but there was always seepage, so there was always need to pump water. Now you can see on this little hill that this mud, just like the muck at the country driveway or by my teeny house, it eventually dries out. So the tips of the elevated parts were starting to dry out. Now we were putting the stuff on the dump truck. We couldn't haul it off site, so the soil had hydrocarbon contamination from years of being a boat harbor and boats pumping overboard. So the material had to remain on site, which is just as well because it's so muddy. If you put it in a dump truck, you're going to dribble down the road, and then you're going to be in a world of trouble because it's really nasty. And while we were doing this, unfortunately, we had to shut down the crew in the pump station TRS because we were raining drops of mud everywhere. Made a big mess, but couldn't really help it. Couldn't swing the other way. So we just pushed the dirt to the side and just tried to keep the dump truck running. That was the main thing, is to keep him having a spot to dump so we wouldn't stop progress. And the birds loved us because apparently we were stirring up little bugs and stuff. Not sure. So with the majority of the muck removed, and as things dried out, we're able to go around the perimeter, over dig a little bit, and put a lot of expensive stone, and start forming and placing the bottom ring girder, which is concrete. Now, as per our request, the engineer designed it in a whole bunch of squares so that it'll facilitate, because we got to remove this thing at the end. So, bunch of chunks. You can see that big rebar. That's the lifting eye for us to pull them out later on, 2 per bracket. You can see the brackets welded to the sheets. The chunks of concrete, the ring girder. The concrete ring girder is hung from the sheets so that it won't settle. The bars holding the squares together are slip dowels. They're smooth. One side's cast in, the other side has a plastic sleeve over it to aid in removing them later. We put OSB plywood between the concrete and the sheets to kind of help them keep from sticking. We did everything we could to make them easy to remove, but they weren't. They turned out to be pretty tough, but we did get them out. Looks pretty stout, but there's a tremendous amount of pressure trying to crush this Cofferdam with all the people in it, and the Corps and the engineers, they don't play with this kind of stuff. So I don't know what the safety factor is, but it might have been 3. It might be designed 3 times stronger than it needs to be, but I'm okay with that. Here's an instance where they drove the sheets through the interlock, and they came back and welded a patch on the inside. Like I say earlier, they probably weren't. One of them probably wasn't vertical, and they just kept applying energy, and eventually the sheet broke through the interlock and drove next to the interlock. If they would have stopped, or maybe the operator didn't feel it, if they would have picked them back up and drove them down together, probably wouldn't have happened. You never know. It might have been a defect in the sheet, but they patched it with this welded flat sheet, and now the concrete is poured in front of it. Here's another example of the power of that vibratory hammer. They didn't have a special set of jaws for picking up round pipe. They only had the flat jaws for the sheets. So to handle these pin piles, they cut out half of the pipe and then just slid the jaws over the half round that's left, and the jaws just crushed it flat. And that made for safe being able to pick it up, and it also makes it able to transfer the energy of the vibrations to the pipe. So by this point in the job, we had geared up pretty well. Probably had 30 or 40 people, I don't really remember. Our working area, our access point, is getting very crowded between the 2 cranes and all of my stuff and all the deep foundation stuff, fuel tanks, pumps, etc. Getting kind of crowded up there. We were pouring multiple concrete blocks every single day, and eventually we finished it out all the way around. So we may have forms that fail, concrete forms that fail. We'll have equipment that breaks. We'll have anchor bolts set in the wrong spot, but we will not have a TRS failure. It is just it's the way these things are designed. Even if you run into it with a barge, it's not going to fail. So with the bottom ring girder complete, all the concrete placed, we were allowed to continue excavation. So we got out in the middle and dug the footprint of the sector gate to about a foot lower than needed, or maybe a little more, and then we put in sand and stone to have a safe, stable working area for the pile drivers. They need to be able to set templates, and they need to stay put. So they started moving their stuff into the excavation, and we moved our stuff out. We don't like to work near them because they have so much stuff high up in the air. And I think this is a good spot to end this video. If you guys like it, let me know. I'll do another one on the pump station TRS, and then the whole build if I have some viewers watching these things. So okay, thanks for watching.